Welcome to this M1 video on centers of mass. So far what we've looked at is uniform rods and uniform beams. And in those, the centers of mass, or the center of mass, is always at the midpoint. Now, if the rod or beam is non-uniform, then the center of mass is not necessarily at the midpoint of that rod or beam. Okay, it could be somewhere else. So for these kind of questions, then, if we're not told where it is, we have to consider moments due to the weight and find out potentially where its center of mass is. But other than that, there's no real difference between this and the last video. Okay, the difference just simply is that the center of mass is not necessarily in the center of the rod or beam. But don't take my word for it. Let's look at the first example. So here we have Paul and Peter sitting on a non-uniform plank AB. So I'll just draw that first of all. So there we have it, a non-uniform plank AB. And that's mass 30 kilograms, but I can't put where it is yet. And its length is 5. The plank is pivoted at M, the midpoint of AB. So here in the middle is M, the midpoint of AB. We'll put it there. So this now leaves me like 2.5 meters either side. The center of mass of AB is at C, where AC equals 2 meters. So there is the center of mass. It's 30 kilograms and it is 2 meters. So that's half a meter in between there, C and M. Okay, Paul has a mass of 40 kilograms. Peter has a mass of 30 kilograms and sits at A. 30 kilograms. Where must Paul sit for the plank to be horizontal? Okay, so for the plank to be horizontal, Paul must sit this side of the pivot, because obviously if he sat this side, it wouldn't be horizontal. So Paul has to sit somewhere on this side, so we'll call that there, 40 Gs, and we're going to say, A, let's call this P for Paul. Oh, Paul and Peter. So that's a little bit annoying. So this is Paul. Okay, so A to Paul equal X meters. Okay, so that's what we're gonna kind of deal with. Now, we need to basically take moments. And the easiest place to take them in this case would be M. Because if we take moments about M, then we don't have to worry about that normal reaction R. We don't have to find that first. Okay, so we're going to take moments about M. So these two forces will rotate it this way, anti-clockwise. So that will be 30 kilograms. I'll put kilograms there. Let's put that as G. So 30G times 2.5 plus 30g times 0.5. So those are the ones going anti-clockwise. And the ones going clockwise will be Paul's weight, which is 40g times, now this will be x is going all the way to a, so x minus 2.5. Okay, and that'll be the distance to m here. So this distance is x, so x minus 2.5 will be this distance. Now all I need to do is kind of work all this out. There's g in basically everything, so I will be able to get rid of that g, but I'll do it in a moment. So we got 90g on the left, 40g times x minus 2.5. So we'll cancel the g's, and then we'll do our 90 divided by 40 is 9 over 4, or 2.25 equals x minus 2.5. So x is, adding the 2.5 on, 4.75. Okay, so Paul must sit 4.75 meters from A. So Paul, or 0.25 meters from B, however you want to describe his position there. So that's the first one, our first non-uniform plank. As you can see, it's relatively straightforward. It's just now we cannot assume that the mass, the weight of the plank is acting in the center. Okay, so we've got to read the question carefully. Let's have a look at another example. So in this example, we have a non-uniform rod AB of length 4 meters and has weight 25 newtons. It is in a horizontal position resting on supports C and D. So C, let's put them up there, C and D, where AC equals 0.5 and AD equals 3 meters, so this will be 1 meter there. Okay, and that will mean that's 1.5 meters, so in the middle will be 2.5 meters to give me my 4 meters altogether. The magnitude of the reaction at D is twice the magnitude of reaction at C. So 2R and R. Find the distance of the center of mass of the rod from A. So we'll put the center of mass somewhere there. We'll call it C. And we'll say that this distance here is x. So AC equals x meters. Okay, and that was 25 newtons. So we've got all of our values on here. Now, what can we do? So we've got our two reactions. So let's find our value of R first of all. So let's resolve vertically. And that means that we got R plus 2R equals 25 newtons. So 3R equals 25. So R equals, well, it's 25 over 3 newtons. We'll leave it as that fraction rather than 8.3 recurring. Okay, but I'll store that as A in my calculator to use later on. Now we want to take moments. Now, taking moments, the easiest thing to do is to take them about A, because then we can use that distance X. Now that means that the upward ones will give me an anti-clockwise motion and the downward ones will give me a clockwise motion. So that is 0.5 r plus, now d is 3 meters from A, so 3 times 2r equals 25 times x. So that is 6.5 r equals 25x. So 25 over 3, which is r times 6.5, gives me 325 over 6. Divide by 25 gives me that x is 13 over 6, or 2.17 meters to 3 significant figures. Okay, so the center of mass is 2.17 meters from A, and this is 3 significant figures. Okay, so that is then finding the center of mass. Again, nothing too challenging, just resolving vertically and taking moments. And obviously we could take moments about any point here, but it was easier to take it from A because that is the distance I had to find that distance from A. Okay, so nice short little introduction, nice little quick video. If you found it useful so far, hit that like button. If you're yet to subscribe, please consider hitting that subscribe button. And if you wish to help me out financially, hit that join button. Otherwise, let's look at the questions. So I've got 3 questions for you today, all past exam questions, and they're quite large, so I can't really fit them on the page all at once. So I'll do them one at a time. So pause the video now. Welcome back. Let's have a look at the solutions to this one before going on to the second question. So we have a plank AB, like so, of length 4.8 meters and a load of mass 15 kilograms is attached to the plank at point C. So that is 15G, where AC is 1.4 meters. The loaded plank is held in equilibrium with AB horizontal by 2 vertical ropes, one attached at A and the other at B. The plank is modelled as a uniform rod. So in the middle then, 24G, and it's 4.8 to 2.4 meters there. And this will be 1 meter in between them. The plank is modelled as a uniform rod, the load as a particle, and the ropes as light inextendable string. Find the tension. So we've got tension of A and tension of B. Find the tension in the rope at B. So for this, let's take moments about A. So take moments about A, and that will mean my 15g times 1.4 plus 24g times by 2.4 is going to be equal to TB times 4.8. And now it's just a matter of rearranging for TB. And that is 160.475 newtons. Or 160 newtons to 3 significant figures. Now let's move on. So that was A. Let's look at part B. So the plank is now modelled as a non-uniform rod. With the new model, the tension in the rope at A is 25 newtons greater than the tension in the rope at B. Find the centre of mass of the plank from A. So this is what I've got now. The tension in the rope at A is 25 newtons more than at B. So T plus 25, and this one would be T. And this centre of mass now is not in the centre, is X distance from A. So find that centre of mass. So let's first resolve vertically, and then we can find out what T is. So T plus 25 plus T equals 15g plus 24g. So 2T equals 39g minus 25. So T is 178.6 newtons. Now we need to take moments. And we're going to take our moments about A. So that means that the 15g times 1.4 plus 24g times by x is equal to t times by 4.8. And of course we know what t is, don't we? So t times 4.8 is 857.28 minus 15 times 9.8 times 1.4. So that, taking this away, that gives me a value of, so 24gx equals 651.48. Now we divide by 24 times by the 9.8, and we get that x is equal to 2.77 meters to 3 significant figures. So centre of mass is 2.77 meters from A, and this is correct to 3 significant figures. Okay, so that is question 1 done. Let's have a look at what question 2 is. So here's number 2. Pause the video now. Welcome back. Let's have a look at how we're going to solve number 2. So first things first, let us sketch what's happening. So we've got a beam of length, of AB of length 10 meters. It's supported by a smooth pivot at its center. So that'll be like C, at its center we'll call it. Sophia has a mass of 30 kilograms and sits on the end A. So Sophia sits here and she has a mass of 30 kilograms. Her brother Roshan has a mass of 50 kilograms and sits at a distance x. So he's probably going to sit somewhere over this side. So that is 50G and sits at a distance X from C. So this is going to be X here is from C. The beam is initially modelled as a uniform rod. So this beam is initially modelled as a uniform rod. So this is going to be my weight in that centre there. Using this model, and normal reaction, of course, in the centre there. Using this model, find the value of X for which the seesaw can rest in equilibrium in a horizontal position. So for this, we want to take moments about C, because we don't know W and we don't know R. So that means that 30G times, now that distance to the centre will be 5 meters. So 30G times 5 is going one direction, and then the 50G times X is going in the other direction. So 30G times 5, so that's 150G equals 50 GX. Now, the G's will cancel, divide by the 50, so X equals 3 meters. So this distance X here is 3 meters from the center. So that is part A done. So that is part A. Now let's look at part B. State what is implied by the modeling's assumption that the beam is uniform. So the centre of mass of the beam acts at the midpoint of the beam. So there we have it. So now we're on to part C. Now, Roshan finds that he must sit at a distance of 4 meters from C for the seesaw to rest horizontally in equilibrium. So the beam is now modelled as a non-uniform rod of mass 25 kilograms. Using this model, find the distance of the centre of mass of the beam from C. Okay, so we've got something like this. Now, we know that originally when the weight was acting in the centre, this was at 3 meters. So if he's gone an extra meter this way, then the mass, the weight of this beam must act slightly to the left of this. So I'm going to assume it is to the left here, and it's 25G, and this distance here is X. Okay, which I'm trying to find. Actually, let's call this distance Y, because we had an X earlier on. Okay, so using this model, find the centre of mass of the beam from C. So there we go. Now from this, we can find the centre of mass. So let's take moments about C, because the only thing that's unknown is that distance Y. So take moments about C. Now let me just make a little bit more room. So we have 30G times 5 to the middle plus 25G times by Y is going to be equal to 50G times by 4. So that will mean that 25GY will be equal to, so this is 200 and this is 150, so that will mean it's 50G. So y equals, divided by 50g by 25g, y will be equal to 2 meters. Now, I don't need to say where it is because I have labelled it on my diagram, but I can say, you know, the centre of mass is 2 meters from the midpoint towards Sophia, or end A. Okay. Now, if I'd guessed the wrong side, like say I'd guessed it was on this side, my y then would be negative to show that it's actually the other side of that centre, that midpoint. Okay, so I didn't have to worry about getting it right, but guessing right does make my life a little bit easier. So that is question 2 complete. Let's have a look at number 3. So here we have the final question. Pause the video now. And welcome back. So let's look at how we go ahead and solve this one. So we've got our uniform rod here, 25 meters long and weighs 80 newtons. It rests horizontally in equilibrium on ports C and D as shown in the diagram. The center of mass of the rod is 10 meters from A. So the center of mass is, say, here. So that's 80 newtons. And this will be another 4 meters from C, because it's 10 meters from A. A particle of weight W newtons is attached to the rod at point E, where E is X meters from A. So we've got a rod here of particle of W, and this is going to be, if I draw a line, X meters from A. The rod remains in equilibrium and the magnitude of the reaction at C is 5 times the magnitude of the reaction at D. So if D is R, C is 5R. Show that W equals 400 over 25 minus 3x. So if I take moments, I'm basically I can't get rid of both of the reactions, can I? Because taking moments from C will still leave this one, which leaves me with 2 unknowns. Okay, or 3 unknowns including the x. So we need to find out what R is first. So we need to resolve vertically. So that is 5R plus R equals 80 newtons plus W. So 6R equals 80 plus W. R equals 80 plus W over 6. So that is my R. Now we need to take moments. So we want to take moments about, well, we could take it about A. We could take it about C. That will, give me, get rid of one of the R's, makes it a little bit easier, I suppose. Yeah, let's take moments about C. So that means that, because there's no forces this side, so this force going up will go anti-clockwise, and these 2 forces going down will go clockwise. So let's do the anti-clockwise first. So R times 14, because 25 meters, so C is 19 meters from B, and then this is 5 meters, so there is 14 meters in between these two. Okay, and that is going to be equals to 80 newtons times by 4 plus W times by X minus 6. Because this is X and this is 6, so this distance is X minus 6. So R is 80 plus W over 6 times by 14 minus, now 80 times 4 is 320 equals, now W times by X minus 6. So we've got two W's on here. So let's take a step back and just keep everything on the same side. So I'll keep this on this side for now, and let us multiply by 6 so that we can get rid of our fraction. Like so. So 14 times by 80 is 1120 plus 14W equals 1920 plus 6WX minus 36W. Now it's probably easier if I don't expand that. So let's leave it as 6WX minus 6. So 14W minus 6WX minus 6 equals 1920 minus 1120. Let's factorize out the W, so that's 14 minus 6x minus 6 equals 1920, 800. So W equals 800 over 14 minus 6x minus, plus 36. So 36 plus 14 is 50. So we've got 800 over 50 minus 6x. We're almost there. Now we can take out of this, so 800 over 2, and that's 50, sorry, not 50, that'll be 25 minus 3x, and cancel the 2 with that to leave 400, and there we have our answer. So therefore W equals 400 over 25 minus 3x, which is what we were looking for. So there we have it. I'm sure you guys might have done a little bit different or taken moments about A and so on. I don't know. Let me know in the comments if taking moments about A was easier. But here we have it. Got the answer, and wherever you take the moments from, you should be able to get down to the answer in the end. So that brings the end of this video. and there is just one more video in this series and the end of M1 playlist. Okay, so stick around for the final video on tilting. But if you found this video useful, hit that like button, don't forget to subscribe, and please consider hitting the join button even if you only do it for a month. Peace out, see you in the next one.